Your computer, phone, smartwatch, website, or any other gadget on a wireless network has its IP address. The internet runs because of the IP address. IP stands for Internet Protocol and address means the unit number assigned to every device on the internet. It is same as in our real world. We have unique addresses for everyone, which is why if you send someone something, it gets delivered right to them. Same in the internet world, every device has its address, the IP address. To check your computer's IP address, you can type ifconfig in your Linux or Mac OS terminal and ipconfig in your Windows terminal. You will see details about your network. Like here, this is my IP address 192.168.43.199. There are 4 sets of numbers separated by these periods and these numbers can range from 0 to 255. These sets are called octets because each set is of 8 bits, that is 1 byte, cause 1 byte is equal to 8 bits. That means the size of complete IP address is 32 bits, which is similar to 4 bytes. Computers see everything in the binary language. Each set is of 8 bits. If I convert this IP address into binary form, it will look like this, 11000000.101 and so on. Here, 1 means that the bit is on and 0 means it is off. Every bit has its value. To convert this binary into decimal, write the powers of 2 starting from 0 for the first bit till the end, so that it will go till 2 raised to 7, that is 128. These are the values of each bit. By adding the values of the bits which are on, we will get our decimal value of the octet. In the same way, we can get the decimal values of the other octets to get the IP address in decimal form. To convert the IP address from decimal to binary, we can take the decimal value of octet and then start from the highest valued bit and ask ourselves, can we subtract 128 from 168? Yes, we can. So write 1 for the corresponding bit and then move to the next with the remaining decimal value. In this case, it is 168 minus 128 that gives us 40. Ask the same question again. We cannot subtract 64 from 40, so we will write 0 for that bit and move to the next one. Yes, we can subtract 32 from 40. Let's write 1 here. Now 8 is remaining. We cannot subtract 16 from 8, so we will write 0, and then we can subtract 8 from 8, so we will write 1 here. Now that we have nothing remaining, we will write 0 for the rest of the bits. This is how you can convert an IP address from decimal to binary. If all the bits are 0, the decimal value will be 0. If all the bits are 1, the decimal value will be 255. This is why octets range from 0 to 255. There can be 4.3 billion IP addresses in this set of 4 formats. These IP addresses are divided into 5 classes, A, B, C, D, and E. In class A, the value of the first octet is from 1 to 126, and in class B it is from 128 to 191, and in class C it is from 192 to 223, and in class D it is from 224 to 239, and then the last one, that is class A, it is from 240 to 254. Where only classes A, B, and C are available for public use, Class D is for multicasting, sending data to the group of networks who want that data, and Class E is for research and development. Here, the first octet starting with 127 is missing. These IP addresses that begin with 127 are known as loopback addresses. We generally call them localhost, where we host apps locally for development or testing purposes. But we ran out of IP addresses a long time ago. To fix this problem, INS first step was to make some IP addresses private, which are used to transfer data between local networks. So now, instead of having a public IP addresses for every device, they have private IP addresses by default. And it makes sense. Like, if I want to give something to my neighbor, I won't be using the postal system. I will give that thing to him directly. In the same way, these private IP addresses are used to transfer data between local devices. If some device wants to access the internet, then your router connects that device to the internet with your public IP address provided by your internet service provider. This process is done with the help of NAT, which is Network Address Translation. Your router manages NAT, so you don't have to worry about it. To know your public IP address, do a quick Google search. What is my IP address? from any device. You will get to know your public IP address assigned by your internet service provider. But making some IP addresses private was not enough, so IPv6 was introduced. The older version is known as IPv4. This is how it looks like. 2001 is to DB, 8 is to 333, and these are separated by colon. As I told you earlier, the length of IPv4 is 32 bits. The length of this IPv6 is 128 bits, with each part of 16 bits. That's why these parts are called as hexted. There are 8 hexteds in IPv6, so 16 into 8 gives us 128. The range of every hexted here is from 0 to 4 times f. If we convert 4 times f from hexadecimal to decimal, the value will be 65,335. So every hexted ranges from 0 to 65,335, wherein the IPv4 octet ranges from 0 to 255. Due to this massive range of every hexted, we can have 340 IP addresses in IPv6. Even though IPv6 was launched in 1955 and is better than IPv4 in many aspects, approximately only 37% of the internet uses IPv6 today.